As travelers, we've all had those moments at the airport where logistical things get super difficult. And having to manage multiple suitcases at the same time always makes things even more challenging.
So as a solution, we wanted to create something that could hold your suitcase and also follow you around.
Hello, we're Team 18, and this is what we came up with.
So first, let's talk about the mechanical side. We have the transmission, as you can see on the side. The driving sprocket is located here, and the driven sprockets are located here, each of which are connected on the same axle to the wheels. The back wheel is a traction wheel, the front wheel is an omni wheel. Over here, you have an idler sprocket which tensions your chain, and that connects all the sprockets together. In the back, you can see two compliancy wheels which are tensioned to hold your suitcase in. At the bottom here, you can see two load cells which can determine and figure out what weight your suitcase is.
Well, now let's get to the electronics section. We have the main switch, the weight sensor and the lights, Bluetooth module for supporting cell phone control of the robot, ESP32 as our microcontroller, the AI camera for our AI tracking mode. We have several level shifter here so that we can feed information to the L298 wall motor controller, which empowers the two motors down here. They're a Pololu 32.7D 30-to-1 ratio motor. We also have a LiPo battery to power it and a 12-volt voltage regulator to regulate enough current.
So now that we've introduced our robot, let's talk a little bit about how it works. This robot supports manual mode, which means that this Bluetooth module here can connect to any cell phone. The cell phone is able to support a controller interface in which you can move the robot forwards, backwards, left, and right, as well as being able to change to different speeds. Both motors implement PID control, which means that the speed and direction of our robot can be precisely monitored.
Another mode that our robot supports is the AI tracking mode. It uses Husky lens, which can pretty much recognize any object with specific shape and color. And once it does recognize, it will then put a frame around that object. The frame, when let's say when the object moves away from the camera, the frame becomes smaller. If the object moves left and right, then the frame also moves left and right on the screen. By interpreting these changes on screen, we can then translate them into actual speed and direction changes of each wheel.
One of our proudest mechanical subsystems is the transmission. This system incorporates a lot of the ideas taught in ME 102B and also realizes our tank drive setup. This allows us to only use two motors to control the entire movement of our robot.
And because we didn't do separate steering, what we do instead is having two omni wheels on front. These omni wheels enable smoother turns and also reduces unnecessary friction and wear.
Making robots is cool, but without the hardware, it's impossible. McMaster has a great cat.
And thank you so much for watching this video. This is Team 18, and we hope you like our robot.
Here we can demonstrate the weight sensor D warning.
Take one off, boom. Put that on.
And thank you so much for watching. And thank you so much for watching this video. And thank you so much for watching this video.